Welcome to Unit 1.02. Today we're going to continue on with looking at quadratic functions and using them to answer questions about real-world problems. So a couple of words before we get started. The first is to make sure that your header is correct. So you're going to put the unit number as well as the aim at the top of your paper, and also enter this in your table of contents so that you can then go directly to that page if needed. Before you get started, you might want to review some of the concepts in the first video. Certainly if you didn't take a look at that one, you're going to feel a little lost here. Particularly reviewing the vocabulary. What does function notation look like? What does it mean? What are the roots slash zeros of a function? How do we find them? And then also looking at the quadratic formula and understanding what it's actually telling you. Okay, so if you have those, you'll be in good shape. But if not, take some time to review them. All right, so here we are taking a look again at Gil and Cedric, and they're practicing their soccer skills, and we know from the introduction that they each kick a soccer ball. Gil kicks one at a 45-degree angle, and Cedric kicks one at a 53-degree angle. And we're given the two functions that model the height of each kick over the number of seconds that the ball travels in the air. And so thinking about our protocol of understanding the problem first, and then planning, and then solving, and then checking, the understand piece is going to be probably the most important because it's really going to key everything else. So let's kind of talk about how we'll understand this problem, and I'm just going to, as you should as well, I'm just going to write it over here so I can check off as I go through that I've completed each piece. So to understand the problem, we need to go through and make sure that we understand each piece of information we're given, and then perhaps create something from that to help us understand it better. So the information that they give us are the degrees at which, the angle at which each kick is being made, and more importantly, the function that models the height over the time. So to understand each function, we need to understand what the independent and dependent variables are. The independent variable here is time. In fact, almost every single instance that we have time involved in a function, it's going to be the independent variable. And that should make sense because a lot of things will depend on the time you're at. And in this case, what depends on the time is the height. As we're told, the height, g in feet, of his kick over t seconds. So if we have that information clearly stored in our head or written down, and I encourage you to write it down, then we have a good understanding of what we're given. And then to kind of finalize our understanding, we are given two functions. It would be really nice if we could graph those out, because a visual representation is going to more clearly just show us what's happening in the situation. So here we're given a graph, and it's not quite complete. We'll notice that both axes are not labeled, and that's going to be very key, right? If we don't know what the axes represent, it's going to be impossible for us to interpret the graph. So the y-axis, of course, representing the dependent variable, which is the height, and that's in feet, and the independent variable, which is time, measured in seconds. Okay, and as we go through the problem, we're actually going to kind of notice some key characteristics about quadratic functions, which in general we're also going to want to label when we graph them. But we'll wait for that. So at this point, I have a really clear understanding of the situation, and now I can move on to each individual question and feel more confident about answering it. So with each individual question, there's still an understanding piece where I have to make sure I know what the question is asking me, and then I can go ahead and create a quick plan for how I'm going to accomplish that. So what I encourage you to do right now is pause the video, go through these, and try each one, okay? And then once you've completed that one, go ahead and press play. We'll talk about it a little bit, and then once we've covered that, pause again and try each one. Remember, you're only going to get better at these types of questions if you fail first and then see where you messed up. That'll help your brain remember more clearly certain trends and certain pieces of information. Okay, so I hope that A went well for you. Here we want to label where the soccer ball begins moving upward, and this is pretty straightforward, right? The moment at which the ball is kicked would be where it starts moving upward, and that is going to be at time 0. So that will be at the origin, and so I'll label that with an A, and I can circle it too just to make it very clear. All right, moving on to B, a label where the ground is represented on the graph. And this can be a little tricky sometimes. Notice that the height is represented by the y-axis. And so where would the ground be? Well, it would have a height of 0, right? That would be what the ground is. And so if you think about traveling down your y-axis until it gets to 0, well, that would be where the x-axis is. And that makes a lot of visual sense because it's a horizontal line. And so the x-axis is B. All right, C, at which angle does the soccer ball reach the greatest height? And we want to justify here. So what we're trying to figure out is which soccer ball goes higher. And just by looking at our graph, it's very clear that Cedric's ball is going to reach a higher point than Gil's. And we can justify this just by looking at the graph, right? There's really a large discrepancy between the two. What we do want to think about is how we might actually find the height, and we're going to get to that one in letter E. But for now, we can think about justifying just by mentioning the graph here. So what you want to do is pause really quickly, write out your answer, right? Cedric's reaches a greater height as evidenced in the graph. It appears that Cedric's ball reaches approximately 45 feet, whereas Gil's only 25 feet. All right, D, which ball reaches the ground first? Justify by finding how much sooner that ball lands. So there's two parts here. The first is which ball reaches the ground first. And since we already know where the ground is, what we're looking for is which ball is going to hit our x-axis first. Okay, so that's where I'm understanding what the graph is, or what the question is asking me to find. And so I can look just at my graph, and I told you that, right, the graph is going to be really helpful here. Notice how many questions it's knocking out. So if I just look at my graph, I can clearly see that Gil's ball is going to intersect the x-axis at what appears to be a little more than 4 seconds, whereas Cedric's kick isn't going to hit the ground until 6 seconds. So that takes care of the first part, right? Which ball reaches the ground first? That's clearly going to be Gil's ball. So I'm actually going to go ahead and show a little work here. So we know for the first part of the question that Gil's ball reaches first. All right. And now we need to justify by finding how much sooner that ball lands. So here there's two pieces to this question. The first is we need to know at what time Gil's ball lands, and then we need to know at what time Cedric's ball lands. Okay? So let's think about what this question is really asking. If it's asking when the ball lands, that's another way of saying that it's asking when the ball will hit the x-axis or has a height of 0, right? Because that's when it will land. So this means that the height is going to be equal to 0, and what we're looking for is the time. And this is very important because this is the understanding piece where we're understanding what it is that we're trying to find and also what is it that the question tells us. So now we can come up with a plan. How are we going to find the value of the time for which the height is 0? And remember, the height is the y value, and we're searching for the time. So this gets back to the quadratic formula. We can make the y value 0 and solve for the independent variable using the quadratic formula. So my plan is going to be to set the height equal to 0, solve for the time. All right, so we're going to do this for Gil's and Cedric's. So let's go ahead and do Gil's first. I use blue over here. So when will Gil's ball hit the ground? Well, the equation for the height of Gil's kick is -6 t² plus 25t. And what we're going to do is we're going to set that equal to 0 and solve. So we set it equal to 0, and we're solving for t. We want to solve for t. Now, we could go through and actually use inverse operations to solve for t, but that would be a waste of time, right? We did the general case. That's why the quadratic formula is so helpful. And so we know that the value of t that will make this expression equal to 0 is given by negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so I'll go through this one quickly, and then for Cedric's, I'll let you do that one on your own. Here the b value is 25, so we have negative 25 plus or minus the square root of 25 squared minus 4ac. Now, before I write down 4 times a times c, let's just remember that a is negative 6, and there's no c value. So in other words, the c value is 0. So we'd have something times 0, which is of course going to be 0, and so there's no need for us to write that down. And this is all divided by 2 times negative 6, 2a, which is going to be negative 12. Okay, so a couple of things that we can notice here. The square root of 25 squared, well, square root of something squared is just going to be whatever that something is. You could test that out with the square root of 4 squared. And so what we have is that the time is going to be equal to negative 25 plus or minus 25 divided by negative 12. And this will give us two options. We can either add 25 or subtract 25. And so we get two options here. The time will either be equal to negative 25 plus 25, which is 0, so 0 over 12, which is 0. Make that clear there, 0. Or t is equal to negative 25 minus 25, which is negative 50, over negative 12, and that is equal to positive 4.2. Now it's important to put units here, right? Time is measured in seconds, so this would be seconds. I'll use an S there. And here we can interpret these answers. 0 seconds, that's clearly the very beginning, and obviously the ball is at the very beginning at 0 seconds. It's at 0, it's on the ground. And 4.2 seconds, well, this is clearly where Gil's ball hits the ground. Okay, so now we want to do this same thing for Cedric. And so we're going to follow this same idea, right? We're going to take Cedric's equation, or Cedric's function. We'll set it equal to 0 because we want the height to be 0, and we're searching for the time. And you can solve that one on your own. And you can check your answer because it's very clear that Cedric's ball should hit the ground at 6 seconds and at 0 seconds. So you can check to make sure that you've got the question right. All right, let's go ahead and move on to E here. When will Gil's kick reach its maximum height? And so the question now is asking when, in other words, what is the time that Gil's ball will reach its maximum height? And so we need to interpret this maximum height here. What does that mean? Well, just looking at the graph, its maximum height for Gil appears to be right here. Okay, and so if we were to look at the time, we'd say, about 2. All right, but we want to be precise. Remember, we need to attend to precision. And so we want to find exactly when this occurs. So it's helpful to remember what this point is called. This is called the vertex. And how do we find where the vertex occurs? Well, we can remember that the vertex occurs at an x value equal to negative b over 2a. Okay, that's something that we have learned previously. And so for question E, we know that Gil's ball is going to reach its vertex when its independent variable, which in this case is t, is equal to negative b over 2a. Now for Gill, we have the function given by negative 6t squared plus 25. So b is 25, negative b is negative 25, divided by 2a, which is 2 times negative 6, or negative 12. All right, and so we can go ahead and divide that, and we'll get approximately, and so I can actually use this squiggly equal sign, which means approximately 2.08 seconds. And this makes sense based on my graph, right? I'm checking that my answer makes sense. And so I can write this up now and say Gill's kick will reach its maximum height at 2.8 seconds. I know this because the vertex, which is the maximum point, occurs when t is equal to negative 25 over negative 12, which is approximately 2.08. All right, so hopefully that was helpful in seeing how we can go through a problem like this and utilize our math skills to make sense of the real world. And what I want us to call attention to is the fact that there are some key characteristics of these quadratic functions that are going to really help us make sense of situations. So a couple of these different pieces. The first are the roots, right? The roots here were very helpful. That was when the ball was going to hit the ground, and so finding the roots is always going to be very helpful. Another is the vertex, right? The vertex is very helpful, and if we actually remember from Algebra 1, we know that these functions are symmetric. And what that means is that the roots are going to be just as far, one root will be just as far to the right, and the other root will be the same distance to the left of our vertex. In fact, that's why we see negative b over 2a show up in our quadratic formula. And then the last piece that's really helpful is the y-intercept, right? The y-intercept is when the x value or independent variable is equal to 0, and that usually gives us kind of an initial value, right? We'll be dealing with time a lot, and so when time is 0, is telling you where an object is at that, beginning time. All right, so let's go ahead and actually capture this down, because this is going to be really helpful when we have to create our own graph. We can look at these key characteristics and then graph our function. All right, let's capture the key characteristics of quadratic functions. This will help us move quickly through these problems. And so the first is the roots, also known as the zeros. You remember that definition. I'm not going to go over it again. We can use the quadratic formula to find these after setting our function equal to 0. The next is the maximum or minimum values, and this is also known as the vertex. And the reason it could be a minimum is if you think about a quadratic that opens upward, the vertex there is going to be the minimum. And the x value where the vertex occurs is given by negative b over 2a. Okay, so that's an important one to remember. And the third is the y-intercept or initial value, and we should remember this, right? This is the y value when the x value equals 0, right? Or the y-intercept. So, in fact, we can graph a quadratic function by finding these three things in order. And in fact, you actually only need the first two. So, to graph a quadratic function, find the roots, right? Find the roots, then you can plot them, and then find the vertex, plot the vertex, and then you know what a quadratic looks like. You just draw a quadratic curve through the roots, through the vertex, and through the other root. And in fact, I'll tell you this, and you can kind of look for it yourself, you actually find the vertex while finding the roots. And so I'll let you kind of look at that on your own. But then it's also very helpful to find the y-intercept, and that can just be helpful when we're looking at real-world questions, because that's often a question that comes up. Okay, so when you're faced with a situation where you're not given a graph of a quadratic, you can go ahead and graph it yourself. by finding the roots, plotting them, finding the vertex, which is the max or the min value, plotting that, and then sketching your curve through those 3 points. And then also finding the y-intercept or initial value to help you answer questions. All right, so I'm going to give you one more question for you to try on your own before we show up to class tomorrow. All right, this is one of my favorite problems. It's the springboard diving problem. For any of you swimmers out there, you've probably dove off of a diving board, and this question is about someone who does just that. So what you're going to do is copy it down yourself in your notes, and then you should spend, probably about 15, maybe a few more minutes going through this problem. Things to remember is that you want to understand, have a plan, solve, and then check. All right, so the two really important ones are understanding and having a plan. Okay, so make sure you understand both the equation, maybe create a graph if that's not given, and then for each problem, make sure you know what am I trying to find and what is some of the information that I'm given that can help me find it. All right, so go through, you should have an answer, right, and show your work for each part, A, B, C, and D. Okay, do your best. It's okay if you end up being wrong. That's not a problem, but you have to at least give it a shot. All right, so good luck, and we'll see you tomorrow.